Hello. Today we are going to start a new subject about advanced machine learning applications. There we are going to discuss mainly on deep learning, which is a basic uh, machine learning algorithm uh, form which has become very popular during last couple of years due to its some of its nature uh, which we are going to explain during this lesson. And although this machine learning algorithm, which is deep learning or artificial neural networks, are a form of machine learning algorithm, uh, there are some specific reasons why uh, this was this has become a very popular machine learning algorithm. So from this lesson onwards, we are going to discuss uh, what is deep learning, why it is used, and so on. In this course, first we are going to discuss what is deep learning and what are the machine learning techniques that are the fathers of deep learning and how it has evolved from the earlier techniques, classical techniques in machine learning, and how it has become deep learning and why deep learning is working better than the other machine learning algorithm. And you will also learn how deep learning or artificial neural networks with multiple layers are working, what is its working principle, how they are learned, and how they are designed. So unlike many other machine learning algorithms, you can have different designs in deep learning or artificial neural networks because it is a form of network, as its name says, where you can design different uh, architectures of neurons and different learning units combined together for different purposes. So we will learn how they are designed and what are the rational what is the rationale behind each of them and why we are going to use it, and each of them are successful, and for what for what kind of applications there are or requirements each of the architecture is more suitable. And you will see how they can be explained with statistical and mathematical form without using too much mathematics. And also we are going to explain this lesson, this subject mainly without too much statistics and mathematics, and we are going to explain it with much of intuition for you to understand what really happens inside it. Actually, most of the even the researchers or the scientists uh, who are working with artificial neural networks and deep learning cannot exactly explain what, why, and how each of them, each of the result is has come or generated from these algorithms. But in compared to the classical traditional machine learning algorithms, uh, we are in deep learning. We are going to see its performance or its usefulness in a more pragmatic form, other than going deeper into its theories and proving its working principles. Right? And we will understand some of the deep learning algorithms and its there are different architectures uh, which would be solved, which can be used for solving some of the problems at your hand. And finally, we will learn what is the development trajectory of this subject, because This is one of the most trended subject in these days, where different new research findings are being published into the world, and the field is evolving so fast, and we are moving. Actually, it is not very uh, not highly uh, clear because it's moving so fast, but it's better to have some kind of understanding about the direction which we are moving as much as possible. So for your reference, you can learn this deep learning specialization course offered by deeplearning.ai, which is offered by Coursera, uh, which can be done in for free. And if you want to get a certificate, you have to pay, or can sometimes you would be able to get the financial aid so that you can get the certificate as well, depending on your mm, requirements. And also you can get that free Massachusetts Institute of Technology course, which is an introductory deep learning course. It is given by this YouTube channel in this YouTube channel by Amini, who is another lecturer who conducts this course in MIT. So here I am not going to detail about the books that we are going to do here, because in each of the year, in each of the in several months, new uh, concepts are getting added to this subject. So referring to a textbook is bit difficult, and it takes time for books to get updated, of course. So it's better if you can learn these kind of resources if possible. Right? And also, when you are going to develop these deep learning or artificial neural network models, uh, you would need different forms of Python tools that are required. Basically, the libraries known as TensorFlow and PyTorch. Actually, those are one of the major two families of schools of thought, or different forms of different two library. Mainly, those are the two libraries used by two different types of people. Actually, we can use it, but so it's like you can use TensorFlow for all the types of neural networks, deep learning alone, and PyTorch also you can use PyTorch alone for deep learning. Right? Time to time, some these one of the these libraries are getting much more popular due to some reasons. For example, in the time, the very earlier time, the PyTorch was the most uh, available open source solution for deep learning, but due to its capability limitations and performance issues, TensorFlow took its place, where TensorFlow had most of the APIs and all the features, and it was developed by Google. So it took the hype, and then later again, with the arrival of Transform and so on, the PyTorch has also gained its trend, and its community support and all the supported libraries and features are getting increased day by day. So it is now getting the trend again, somewhat beating the TensorFlow. So there would be different types of some other libraries as well, but these two are the most widely used uh, uh, technologies that are used for developing deep neural networks. And you can learn these technologies for free. There are plenty of tutorials and sample codes that are there in internet, and there are YouTube videos, and there are online tutorials. There are many resources that you can learn these two technologies. And also you can use ChatGPT to generate the code from either one of these platforms. Sometimes it may get correct answer. Sometimes there may be uh, issues or incorrect information provided by ChatGPT. But so make sure that you double check it, and because it's a form of AI, so AI can always get wrong. It's not highly scrutinized by some people, by a standard set of academics or someone who so it would, as it is automatically generated, so there would be some risk of having misinformation. So keep mind keep your eye on that as well, right? Okay, so when you are doing quizzes and exams, don't use ChatGPT unless it is specified, or everything was started to be done by AI. You don't have to do it by yourself. Right? Still, that time has not come, so you have to do these type things which are relevant to academic studies and exams. You would have to use uh, your own mind and your own capabilities without using ChatGPT or any other generative AI, because these tests are designed to test your capabilities of how you have absorbed it, not the generative AI. So, in order to do when you are passing your exams and so on, you should not be using these generative AI tools. So let's first move into the lesson which we are going to discuss from today onwards. Basically, we are going to talk about neural networks, which is the core of this subject module. So, what is a neural network? We can start with it. Actually, we are going to learn about artificial neural network, not just neural network. Right? So, neural networks are something that is already available in the nature itself, not in uh, physical stuff that don't have any life, but these neural networks are highly available in advanced forms of living beings, living organisms like mammals and humans and so on, where you can find where you can find brains, you can find neural networks, right? So actually, the brain is a, a, a wrinkled or a flat layer which is uh, got together uh, as uh, clump of material which is consist of a layer of neural networks. So we are not going to explain how the brain is designed, but you can learn it by yourself. So what you have to know is that the brain contains a lot of neurons. Neuron is a cell. Our bodies are made out of cells. So neuron is a special form of cell where its usage is about processing data. Right? So there are different cells in our body. Some of them are uh, some of them are skin cells to the protect our body from outside the infections. The blood cells, which the red blood cells would take oxygen uh, into the other parts of the body. The bone cells, which are building the bones, and some muscle cells, which are uh, making movements in our body, right? So different types of cells. So these neurons are the cells that are specifically designed for processing data or having some form of intelligence in living organisms. So, so how we are the living organisms these advanced living organisms are different from the rest is mainly dependent based on these activities of neurons in the brain or in other areas. Uh, there are highly connected neurons. You would find if you can you it through a microscope where the neurons are networked together like a mesh, so like a three-dimensional mesh, right? So neuron is something like this where many neurons are connected together using these dendrites and axons. So we will learn what are those, right? So in each neuron can be seen like this where each neuron has a head and a tail like structure here, right? In the head like structure there is a, in the middle of this head like structure there's a, there you can find the nucleus which contains the its genetic material, right? um, and outside this head like structure you can find like fingers like structures which are known as dendrites, and this tail like structure is covered by uh, axon. So this structure is known as the axon, and it is covered by this myelin sheath, right? And this at the end of this tail, there are another set of finger-like structures known as axon terminal fibers. So we are not going to discuss about that. So mainly, what we are interested is are this dendrites and the output signal which is passing through this axon. Right? So when it comes to the organization of these neurons, so you will find that so these dendrites are taking the signals from the other neurons and process it in the neuron, and the output is given by this axon, and this these terminal fibers are connected to the other neurons, where that means the other neurons dendrites are connected to these terminal fibers of this neuron. Similarly, there are many neurons connected to each other like a complex network. This is how these neurons are connected, and each of the neuron is responsible for uh, doing some form of intelligent calculation. So we will see how it is done in a very simple form. So in animals, you can find there are two forms of nerves in animal, where you can find the nerves in the brain, which is known as the central nervous system, and you can also find nerves in the other parts of the body like hands, legs, and so on, which is known as the peripheral nervous system, which is distributed throughout the body. Right? So the peripheral nervous system is connected to the central nervous system, uh, which is responsible for taking very complex intelligent decisions. Right? That is why we say that our brain is responsible for making decisions and so on, because the brain has a lot of neurons in it. So actually it is filled with neurons. So, but when it comes to the peripheral nervous system, they are distributed throughout the body in very thin connections, but they are concentrated towards the spinal cord, and the spinal cord is then connected to the brain, and brain can process the information and take actions and control the whole body using the neuron, using the peripheral nervous system again. This is how the body works. So some of the, actually not only the brain is working as the information processing unit, some signals are processed by the spinal cord itself as well. However, the most of the advanced intelligent decisions, like for example, if we are planning to build a house, right? So that is a very complex decision taken by a very human, by a very advanced form of being known as a human, right? So this, when humans are taking these kind of decisions like how I am going to plan my retirement, and what I am going to do for my higher studies. Those things are processed generally by the brain, central nervous system. So those information can't be processed with the peripheral nervous system. But when it comes to very quick responses that are required, for example, when you put your hand on the fire and you have to move your hand away from the fire, these decisions can be immediately taken by the uh, maybe sometimes they can be taken outside the brain as well. So before it is coming to the brain, the spinal cord itself can uh, take some decision and send a signal to move your hand out of the fire. But when it comes to very complex decisions, your brain has to do some task. Sometimes it takes some time, right? So that means you say that you are thinking and taking decisions. That means this is a very complex process that is happening in your brain. Actually, we have not yet found how the this thinking process happens in a very detailed level, but we have some understanding how these neurons are processing the data in very basic level. So we could we were able to find a simulation simu way to simulate the natural neurons in a computer, right? So that is how the artificial neural networks has come into the play, which we are going to learn, right? And first, we have to know how these neurons are working and how they are modeled by our artificial neurons. In which way, right? So what neurons do is actually neurons are connected them together, forming a neural network. Right? And neural networks can sense signals from which are carrying from the peripheral nervous system, and they can basically they can sense the signals that are coming into the dendrites of the neurons from by the other neurons, and so that is known as sensing. Right? And they can process the signals, and they can emit some signal from its axon to other neurons to take actions, right? So when there are many number of neurons network together forming a neural network, they can do much more advanced operations and take much more advanced uh, decisions uh, due to its nature of organization. So a single neuron can take a very simple decision. So we will learn. We have actually learned about logistic regression. So the something. So a single neuron's action would be somewhat similar to a logistic regression operation. So that is actually a very rough approximation to a natural neuron, but we can, when it comes to our artificial neural network world, that is how we are going to model the processing capability of a neuron corresponding to a natural neuron. Right? So we will learn how this is happening in the real world and how it is simulated by the artificial neural networks. Uh, so, however, uh, first before we start these lessons, you have to understand that these neurons are uh, studied well by some scientists, neurologists, and many neuron researchers, and they have found some of these how these signals are formed and how they are transmitted uh, uh, across this body of these neurons, and how they are transmitted to the other neurons, right? For example, the signals are coming into these dendrites from some connection between the axon terminals from the other neurons to these neurons, and there's a small space in between these neurons is known as synapse in simple, and there are some complex chemical structures that are in between these connections. And when these connections are, when the signals are coming into these neurons, that they are coming as electrical signals, right? Actually, they are small electrical signals that are coming into uh, these neurons, right? And they are uh, resisted by some extent in these dendrites, and they are added together in this head-like structure, and they are uh, trigger triggering some electrical signals as output signals in this axon to generate more signals to the other neurons, right? So this is how a neuron works. So before we learn about artificial neurons, we have to have some understanding how this one works, right? So, however, make sure that this is just a very simple approximation of natural neuron. A real neuron is more complex than what I am explaining here, right? Actually, how a natural neuron works may not have understood very clearly, but and also it would not be that much possible to simulate the very complex forms of activity in a natural neuron, but we could roughly approximate the functionality of a neuron into a very simple, very gross level of functionality. And actually, we could make very successful neural networks out of this simple abstraction model, right? So uh, that is the most wonderful thing about artificial neural networks, where we could copy the nature, and we could make some approximated mathematical models, and using these mathematical models we were able to simulate some neural networks in living creatures, and we were able to make some living not living but learning material in a virtual environment without using real neurons, right? That is the idea of neural networks uh, being used as uh, artificial neural networks, right? And that is why how the artificial neural networks or deep neural networks got successful in today's world. So this is what I have just explained. Although these neurons, how the activity of a neuron is not yet fully understood, our approximation was correct enough to make it successful, right? Uh, so what happens is the same thing that I have explained earlier, where you get the signals from the dendrites, and right. So and from these locations, we are getting the signal, and then the signal uh, would go through some resistance uh, when they are when they are passing through these dendrites, right? So when when the electrical signal is coming into into the body, so there would be a certain resistance from the beginning of the dendrite at the and the end of the dendrite, right? And when the signal is received to the neuron body, right? Each of these signals that are coming to the neuron body uh, with the resistance in each of the dendrite will get added up at the body, right? So not only a single dendrite is getting signals at a time, right? So there are many dendrites in neuron, right? Neuron body. So all of them, or some of them may be getting signals from the other neurons, and these signals will be interrupted or attenuated by the resistance of these dendrites, and they will be added at the body, right? And this weighted So they are weighted with their signals and the resistance, right? And the total strength of these weighted signals are can be taken as the output, right? So you can think that these signals that are coming to the body of the neuron can get added and take them as the output, right, from the axon. But that is not what really happens. Okay. So what really happens is, so once you get the weighted sums of all the signals, those this addition summation of all these uh, weighted sums of signals are not the exact signal that is passing from this output, right? So once this weighted sum is received, it is again passed through some form of activation function, right, which is an nonlinear function, and then only it is passed to the output, right? That is something you have to remember, right? So this, you get the signals to the neuron from these dendrites, and they are going through the resistance of each of the dendrites, and they each of the signal is getting summed up at the neuron body, and then the sum is getting subject is gone through the through a nonlinear function, something like a sigmoid function, right? So which we have learned during the logistic regression, right? So sigmoid means the logistic function, right? Something like logistic function, and then only it is coming to the output, right? Which means when the signal is high, it is the output is not linearly high, right? So when the signal is exceeding a certain point, then the output would start to increase exponentially, and then it would saturate, right? That is how the output would be with the strength of signal that is coming from the body of this cell, body of this neuron, right? So this, because of that, this nonlinear function is can be called as activation function, right? So we can use different activation functions for approximating the uh, natural neuron, right? So this is how it is, how this artificial neuron is approximated with the natural neuron, right? So these are the dendrites, and there's the nucleus. This is the axon, right? So, and this is the approximated model, right? Which is the mathematical model that is used for simulating the uh, natural neuron in our computers, right? So this model is used for artificial neural networks when they are networked together, right? So this is a single neuron in its mathematical form, right? So for each of the dendrites uh, in the artificial form, we have set of inputs, right? X1, X0, X1, X2, up to Xn. Right? So now you can remember, right? So this is something related to linear regression, logistic regression, and so on, right? And this X0 is 1, right? So now we can remember, right? This is related to something like bias, right? So, and each of the input is passing through this resistance, which are so we can represent this resistance as weights like W1, W2, Wn, right? So X1 is passing through the W1. So then the overall signal would be like the X1 W1. This signal would be X2 W2, Xn Wn, right? But in the first case, where X0 is always taken as 1, right? And the weight is taken as B, which is actually the bias term, right? You may remember that, where the bias is a constant value. Constant means this is actually another training parameter, but so we don't take any real input for that, right? We always consider this X0 as 1. So the X0 would be always 1, and the bias would be taken, would be used to train this model, right? So the other parameters are known as weights, and only this parameter is known as bias, right? So the overall formula would be like, now you can remember x0 b, or because x0 is 1, we can simply say b, right? Plus x1 w1, x2 w2, and xn wn, right? Similar. So there can be something in between, right? So this is similar to the overall signal summed up signal that you received at the body of the neuron. So which can be represented by this Z, right? So this is a linear function because these inputs and weights are multiplied together and form a linear function, right? So this Z would be a linear function, and this linear function would pass through this activation function, which is a non-linear function, something like a logistic function, right? So then only it comes to the output, right? So similar to the Y output that you receive from the artificial neuron, right? So now you can map how a natural neuron is mapped to a artificial neuron in today's technology, right? So actually in future there may be much more accurate models in neurons, so that we may get much accurate neural networks with lesser number of neurons and so on. But in the today's technology, today's findings, this is the general form of neuron that we are using. Actually, there are much more somewhat different approximated form of neurons known as Arnold Kolmogorov model. So we are not going to discuss it in this earlier lessons, but maybe later we would be having, if we have any chance, we would discuss them as well. But so these are the traditional artificial neurons that are being used for artificial neural networks, right? So actually this f function can be any nonlinear function, not only the logistic function, right? So we will learn what are the other functions as well that are possible to be used as activation function. So this is the math behind it, right? So you can take these inputs x0, x1 to xn, right? And multiply them with the resistances, which are b, w1, w2, wn. So you will get Z as x0 b plus x1 w1 plus x2 w2 plus xn wn, right? And this, because this Z is a linear function, right? Uh, uh, in order to approximate the neuron, you have to apply it through a activation function f. So we apply this Z through the f function, and you get the y output, right? So which is the output here, right? So now looking at this new artificial neuron, you can get this formula, right? So when you take the f nonlinear function as the logistic function, right? Like, I think you can remember this f we said is 1 over 1 plus e to the power minus z, right? Which is, this is the logistic function or the sigmoid function, right? So now what can you remember? So this formula is relevant to the logistic regression, right? So this neuron can be modeled by simply a logistic regression algorithm, right? So here you know that x0 times b is b because we take x0 as 1, right? So this is exactly the same logistic regression that we have learned, right? So you can simply take and consider a neuron as a logistic regression algorithm, right? However, this is only applicable when you are using the logistic function as the activation function for the neuron, right? So this logistic regression was the earliest form of approximation for uh, neural networks and for neurons, right? So in artificial, of the earliest generation of artificial neurons were logistic regression, right? But there were some issues with this activation function f, right? So which we will be discussing later, right? So scientists or the researchers were looking at different activation functions that were much uh, better, right? So to approximate the natural neurons. So actually not really to approximate the natural neuron, but because our artificial neural networks are trained in a different form where it is known as backpropagation, right? So there are the issues that were causing uh, caused by this logistic regression, sorry, logistic activation function were related to this backpropagation algorithm. So in order to avoid or mitigate these issues, so they have come up with different alternative activation functions other than the logistic function. So one of the most useful and one of the most straightforward and widely used activation function used up even today in most of the cases in neural networks are known as ReLU function, which is known as rectified linear unit, right? So which is a very much more simpler form of activation function than the logistic function. So this ReLU is used as the can be used as the activation function as well, where you would get where you can solve most of the issues that would be coming with logistic function when used in real world artificial neural networks, because when it comes to training, as I said earlier, there were some issues when it comes to training much deeper neural networks. So we will see what our deeper neural networks actually exactly means. So when you are using these kind of scenarios, there were some issues about learning, right? So yeah, you couldn't learn it. So this ReLU activation function is also good alternative for the logistic activation function. So the ReLU was widely used in uh, later generations of neural networks. Right? So here now also, if you are uh, designing a neural network, you can use the rectified linear unit as the activation function for the activation for the neurons that are inside the neural network. Right? So we will see what I mean by only inside. So later, right? So for the output neurons actually, so we will see what are output neurons, input neurons later. And so this redo is a for now what you have to remember is that redo is one of the highly used activation functions in today's neural networks, right? So ReLU is not the only activation function actually. There are many alternative activation functions that were found, right? This is the ReLU function. So that means which is max of 0 and x, right? So this is the 0 point. So if the x is greater than 0, the y would be x, right? If the x is lesser than 0, the y would be 0. That is the ReLU activation function, right? So there are similar different variants of activation functions that were inspired by this ReLU function, which is known as GALU function, uh, ReLU, and so on, right? ELU, Swiss, CLU, Soft Plus, Mish, PReLU, and so on, right? So it's hard switch, sigmoid, soft sign, tan H. This tan H is also another uh, function which is somewhat analogous to logistic function, right? But this one can also be used, right? So some of the so in before the ReLU activation came, this tan H was also used for in most of the cases, right? So there are versions of tan H as well, like hard tan H, where this edge is sharp, like hard sigmoid, right? Tan H string, soft string, hard string, and so on. So you don't have to learn all of these things actually when it comes to practical applications. Actually, we can use ReLU or something else. If the ReLU is not working, maybe you can go think about that. But in most of the cases, you can use ReLU. But what you have to learn is not about checking with different activation functions, but you can there are many other things that you have to change when it comes to designing a neural network, not only the activation function. So So I have added this slide just to make sure that you know that there are many alternatives other than ReLU and sigmoid, right? So although they are there, you don't have to try all of them, right? So you can simply use ReLU because that is proven to be working fine for most of the cases. So so how, let's see now how the neural networks are working and what is their working principle, right? So as I said that uh, a neuron can be simply modeled by a logistic regression algorithm, right? So so a neuron has some form of intelligence, right? When it comes to logistic regression, you know how to train a logistic regression, right? So you use a training data set, and using the training data set, you train the logistic regression, right? Uh, with uh, with this logistic regression uh, algorithm, you can learn the data with it, and you can update the weights of the logistic regression, and you can have some intelligence uh, as the output of this logistic regression, right? So when it comes to neural networks, we don't call it as neurons, right? So we call them as neural networks. Networks means we are using more than one neuron. So although there is a single uh, logistic regression function in a neuron, when you want to use when you want to have much more intelligence, actually you can use many logistic regression function as many neurons work together, right? So that is the uh, advantage of neural networks. You are not using only a single uh, logistic regression function, but you can use many of them together with same data to learn different forms of information, so that you can have a very high level of intelligence. So that is the fundamental of neural networks, right? By increasing the number of neurons, you will have much more intelligence, right? Much more capacity to keep the information in the neural network, because when you in each logistic function, there are certain set of weights, right? W0, sorry, B, W1 to Wn, right? For a single neuron. And if you are using multiple neurons, there would be multiple types, multiple such weights, right? So each of the weight is corresponding to some form of intelligence, right? So when you increase the number of neurons, you would have much more intelligence or much more information stored in the neural network, right? So that is the principal idea of using multiple neurons in a neural network. So in simple terms, you can say that you are running multiple logistic regression functions together, right? So actually, when you are using the logistic function as the uh, activation function, you can say you are running multiple logistic regression. So that is how a neural network is formed, right? Uh, so the training of neural networks is same as training a logistic regression, but because there are many neurons, that means many logistic regression algorithms that are connected in different formats. Its training process is much more different, right? Bit complex than actually much more complex than training a logistic regression algorithm, right? Uh, so here you know that there are different types of neural networks, and depending on the organization or the networking architecture of the neurons, you can have different types of neural networks, right? So which are good at different applications, right? In that case, you can say that although the functionality of neuron is the same, but when you organize them in different ways, you can have different forms of learning algorithms, right? So those are known as different neural networks, right? So we will see what are some of the commonly known neural network types. So the simplest form is when you are having, so I will just draw and show you. For example, when you have a single neuron like this and there are multiple inputs, x0, x0, x1, and xn, right? So these inputs and you get the output, something like that, right? So this is a single neuron, right? So this is the y output. And then you can have multiple such neurons with different inputs. Actually, the same inputs can be corresponding to each of the common input data, right? So you can have different neurons that are operating together, right? This one and input is the same, right? So you can have different y1, y2, and y3 and so on. Right? So in this case, you can see there are 3 neurons are working together to have much higher level of intelligence, right? So the idea is that with this data set, each of the logistic regression function can learn 3 different things about a certain application, right? For example, if you are planning to evaluate the land, right? Land price. Suppose you have a lot of information related to that land, like its deeds, its shape, its location, the uh, the environment of that land, the infrastructure that is available for that land, the social background of that particular land, and so on, right? Many information. So this each of this neuron can learn different factors that are affecting the price of the land. For example, this one can learn the quality of the land, like the area of the land, the quality of the soil, and the water drainage level. And this one can learn about the social background of the land, right? And give a score for that amount. And this one can learn about the legal implications of that land, how risky this would be to get bought by this from that particular seller, because the seller may have some different types of reputations. So right, how so those kind of effects would be maybe measured by these neurons and so on. So each of the different factors related to evaluating the price of a land may be learned by different neurons at the same time, right? And these outputs may be later uh, combined together to another neuron, and maybe we can get the output as the price of the land, right? So you can use another neuron and get these outputs and generate the price of the, sorry about this my handwriting, because I'm using my unfamiliar hand to write this, right? So you can use multiple neurons to have much higher level of intelligence about pricing the land instead of using a single neuron, right? Like we were using the logistic regression. So this type of so if we are suppose if you have only these three neurons together, which where you are using different layers, right? So not combining this layer, right? So forget about this one, right? If that is the case, this kind of neural network is known as a single layer perceptron, right? Because there is a single layer of neurons. So there can be multiple layers, but there's only a single layer, right? So all of the neurons are depending on the same input and generating different outputs. So that is known as a single layer perceptron algorithm, right? Actually, then these outputs can be taken as the inputs for another layer like this one, right? These outputs are taken as the input for this layer, right? So this can be considered as the second layer, right? This is the first layer, this is the second layer, right? So so when there are multiple layers of neurons, this is known as multi-layer perceptron. This is the second type of neural network, right? So only using a single neuron is known as a perceptron, which can be so logistic regression is a form of perceptron. When there are multiple such neurons, we can call it as a single layer perceptron. And when there are multiple layers, we can call it as multi-layer perceptron. And also because the data is flown in a one direction, like from we give the data from here, right? The data is passed from here to here, here to here, and so on in this direction, right? And this is passing from here to here, right? From here to here, here to here, right? From here to here. So they are passing in a non-cyclical manner, right? So that means this output data is not given as the input to any of the layers, any of the neurons, right? So because of that, we are just because we are just passing the information in one direction. This is known as a feed-forward neural network, right? These types of neural networks are known as feed-forward or FNN in short, right? So, and there are some complex neural networks. There where there can be cycles as well. So this input is given to as the input for this neuron and so on. Right? There can be very complex graph-like neural structures as well. Those are known as graph neural networks, which are getting popular these days as well. So, if we have time, we will try to discuss about graph neural networks as well. Right? The other type of very widely known neural network type is known as recurrent neural networks, where there can be cycles, of course, right? So we give some inputs and we get some output, right? And these are the inputs and this is the output, and this output is again passed as the passed as an input for the same. Uh, I don't call this as a neuron because this is a much complex learning component, which is not a simple thing like logistic regression, right? So this is known as a RNN unit or recurrent neural network, right? So we are not going to discuss what the RNN consists of. This is not obviously the logistic regression, right? So, but this is a different form of neuronal unit, right? So the difference is that there are cycles here, right? So this we take the output and the output is given as an input to the same unit, right? So those kind of neural networks are known as recurrent neural networks or RNNs, right? So there are much more advanced forms of RNNs known as LSTMs or long short-term memory networks or gated recurrent units or known as GRUs, right? So those are some advanced versions of RNNs uh, which are avoiding some shortcomings that were well known for RNNs, right? So these LSTMs and GRUs were developed to overcome some issues that were related to RNNs, right? And those are the things that LSTMs and GRUs are the real world neural networks uh, that are being used, but not really the RNNs, right? So these are the real world recurrent neural network alternatives that are used today, right? And also there are other form of neural networks known as convolutional neural networks, so, or CNNs, right? So they are used for processing spatial information. Spatial means grid-like information. For example, if you take an image, like you know that an image is a grid of pixels, right? So there are many pixels in an image, right? So these pixels are organized in spatial manner, right? So this spatial information processing or learning can be done easier with convolutional neural networks compared to traditional feed-forward networks and so on. So we will see why it is the requirement in a later lesson. And not only these neural networks, so there are much more advanced neural networks. So these days, the most widely used, most trendy form of neural networks are known as transformer models, which is much more complex to explain here, right? So those are having different multiple stages of recurrent multiple stages of different neural computations, multiple different forms of learning and so on. So we are not going to discuss here. So this is also a form of, this is a later uh, developed form of neural networks that are being used in large language models, which are used for applications like ChatGPT, right? So let's first start to explore the uh, single layer perceptron, right? Uh, where you can see, so in this case, I have drawn the output, a single layer, right, of the neural layer as in a horizontal manner, right? So you take the inputs like so say x0, x1, xn, and so on, right? So x0 is, we know it's always equal to 1, right? And it is creating the bias. So this is always the bias weight, right? So if we call for this neuron, it is 1, this neuron it is 2, and so on. So it would be B1, B2, and so on, right? Bn or something, Bm or something, right? If there are m nodes, that is the case, right? Similarly, you can have different weights for on different arrows from here to here, right? So these are the outputs, right? You can say like y1, y2, and yn, and so on. So when it comes to this kind of single layer perceptron, you can see that all of these inputs, right? Sorry, let me take off the pen. So here you can see all the neurons are taking the same inputs, right? So this is the nature of single layer perceptron, and they are generating different outputs, right? And each of the neuron can learn different uh, stuff, like as I have mentioned, like in the example of real estate valuation form, valuation model, where each of the neuron can learn different uh, features, sub features, which can be later used by another neural layer to calculate the final price of the land. Right? So this is an example for single layer perceptron. When we have multiple such layers, we call it multiple layer perceptron. And you can have 2, 3, 4, or many number of layers in such a multi-layer perceptron model, right? So when you have many number of such layers, not just 2, 3 layers, but if you have like 10, 15, or even 100 such layers, those are known as deeper neural networks. Deeper means when there are multiple layers, well, there are many number of layers, those are known as deeper neural networks, right? So the advantage of using deeper neural network is somewhat wonderful, actually. So let's see why it is wonderful. Right? not so we don't call it wonderful, but there's a reason for that, right? So the reason is that you can uh, reduce the number of neurons required when you are using deeper layers, right? For example, if you want to have 10,000 neurons in a single layer perceptron, right? For example, uh, mm, say you can have 1, 2, and 10,000th input, right? Suppose this is the 10,000th neuron, right? This is the first neuron, second neuron, and 10,000th neuron. So if we are using this kind of single layer perceptron, you would have 10,000 outputs, right? Y1, Y2, and Y 10,000, right? For simplicity, I will just draw 10 to the power 4, right? So instead of using this kind of neural network, right? So there are inputs as well, right? So different out inputs, right? All of them are connected to all the same inputs, right? So I am not drawing the input, right? So there are 10,000 neurons. So 10,000 is a very large number, right? So when you want to increase the intelligence of the neural network, here you have to linearly increase the number of neurons in the neural network to increase its power, right? So with deeper, the advantage of using deeper neural networks is that instead of using 10,000 neurons, you can make an equivalent neural network with 2 layers, right? This is a single layer perceptron, but with multi-layer perceptron with 2 layers, you can have 1, 2, 100 neurons, right? In a single layer, and another layer also you can have 1, 2, and 100 neurons, and take the output, right? So all of these nodes are connected to all the inputs, right? I'm not drawing it. And each of the outputs of this of these neurons are connected to all of the inputs of second layer, right? So these outputs are connected to this layer, this neuron, and this neuron, right? This neuron is connected to this neuron, second neuron, and this neuron, right? So from here to here, from this first layer to the second layer, it is a fully connected network, right? That means all the outputs of first layer is connected to all the outputs of second layer, right? And all the inputs are connected to all the neurons in first layer, right? So the outputs are given by the second layer, which is Y1, Y2, and Y100, right? So it has found that instead of having 10,000 neurons and for this type of neural network, by using 200 neural networks, 100 neurons for the first layer and other 100 neurons for the second layer, you can have the same power as using 10,000 neurons, right? So that is the idea of reducing the number of neurons in a logarithmic way when we are increasing the number of deeper layers, right? For example, when you can say you can have 4 layers, right? Actually, you can have 10 neurons in each of the layer, and you can have 4 layers, and you can have the same amount of performance, like instead of using 10,000 neurons in a single layer perceptron, right? With multiplayer perceptron with 4 layers, each of the layer having 10 neurons. With 40 neurons, you can simply make the same power with neural network. Uh, that is the idea of, that is the rationale of using multi-layer perceptrons. Right? However, there are some issues with deeper layers, right? So that is what we are going, one of the main things that we are going to learn in this subject. Right? Uh, so why deep learning? Right? So let's again look at the big picture. Right? So when it comes to the traditional machine learning, when you are going to do the uh, when you are, wait a minute. Uh, sorry. So when you are going to use the traditional machine learning, when there are many number of features, uh, when you are unable to use all these features in your machine learning algorithm, you have to reduce the number of features. That means you have to do the feature selection before you apply the machine learning. Right? That means you have to use some algorithm, some careful evaluation of the features, and remove only some of them or combine them together and generate new features and so on. But unfortunately, that is a very uh, difficult task, right? Which needs some effort and expertise. But with deep learning, right, or with neural networks with multiple layers, you can simply uh, avoid that requirement. That means you don't have to select features manually. Right? That means an expert don't have to wait and remove features and add to the machine learning algorithm, because once you that doesn't mean that you can use any random feature into the model. So that won't that will reduce the performance of the deep learning as well. But compared to traditional machine learning, you can actually uh, use it much easier when you have sufficient amount of data when it comes to deep learning, right? Because when it comes to deep learning, uh, in because they are passing through several layers, they are much more intelligent than traditional machine learning, where they can select the select only the required features from the input feature set and pass to the next layer, so that the next layers would do the much more advanced level processing, advanced level calculations uh, on the selected features, other than using all the features that, like when we are using the features in the traditional machine learning. Right? That is one advantage of using deep learning. Right? And when it comes to the second advantage of deep learning is that uh, when you are learning some complex uh, task, or when your problem is much complex, for example, if you want to identify objects in a certain image, right? So you give a certain image and you want the algorithm to identify what is there in this algorithm and in this image, right? So this is a very complex task, right? So the traditional machine learning algorithms can't do it easily, right? So there are ways, some somewhat successful techniques, but none of them are successful as deep learning when it comes to uh, achieving this kind of advanced task. So the difference between the advanced task and simple task are that these advanced tasks need uh, feature selection in, or defining features in several hierarchies. Right? So that is something uh, different from the traditional machine learning. Right? Where in traditional machine learning, you have to properly think about the features that you are providing to the uh, algorithm. But when it comes to machine learning, in deep learning, each of the layer is responsible of using selecting the feature set uh, intelligently and pass a modified version of weighted form of features and form a new set of features to the second layer, right? Second layer would pass another set of features to the third layer, right? So there would be an automated process of creating new features out of the features, and this should drive to a set of automatically generated features in multiple layers. So because of that, it is very, very intelligent compared to traditional machine learning, right? So in this case, you can see there are 1, 2, and 3 neural networks. So you say you have two inputs. These inputs are given to each of these neurons in the first layer, and the first layer is connected to all the nodes in second layer. I'm not going to draw everything, right? So I'm drawing everything. So in this third layer, you can get these outputs, right? In this case, you can see these inputs are taken. Some of the features would be weighted by this layer, and only this first layer would intelligently select the required features among these two features. Maybe this one is not relevant, so it would automatically remove the significance of this feature and generate new three features, right? And these new three features would be used by second layer, and the second layer would create another set of new features which are much more advanced than the features that are generated by the first layer, right? Third layer would use these features, much advanced features, and use these features in a much higher level of hierarchy and take decisions to generate the output, right? Because of that, when you are using these three layers, you can get a very intelligent output compared to a traditional machine learning algorithm. That is the second advantage of using deep learning compared to other machine learning algorithms. So this hierarchy of features, where when it comes to traditional machine learning, you can't generate hierarchies, right? Unless you have a very high level of domain knowledge in the certain field, like as I explained in that example, where you evaluate the prices of lands. You know about the inside features of the features that are affecting the price of the land. So a domain expert can generate these features by hand, but when it comes to neural networks can automatically generate such features, uh, which they are in the natural world or not, right? But however, they would identify, these neural networks would identify such features from the data itself and automatically use these new features to power to give the input to the next layers, right? So that is a very big advantage of using deep learning compared to other machine learning algorithms. So this is a very good example of neural networks using hierarchy of features, right? This is an example that is used in a convolutional neural networks, or simply CNNs, right? So in CNNs, there are several layers of uh, inputs, like I explained here, like first layer, second layer, third layer, and so on, right? So when you move to in this direction, this is how the when you move this direction, this is how the features were looking like, right? So when you so these are this is the uh, this may be the inputs that we are giving, x0, x1, and x2. So right, I am just giving an example, right? So if you give the pixel data as x1, x2, and so on, in the lower level features, in the first few uh, layers of the neural network would identify lower level features, right? like lines and edges. That means by looking at the nearby pixels, it would the this neural network layers will automatically try to identify different orientations of edges, like line, this line, this line, and so on. Right? By using at the differences in the edges, these neural networks, the neurons in this layer, this lower level layer, was able to identify different orientations of lines. Right? So this line is a very basic structure that is building up a very complex image, right? Like faces, right? Inside the faces, there are very basic constructs in an image, like these edges, right? So this, if you try to do it by yourself, you would have to manually try to write write code to generate the edge features using edge filters and so on, right? So we, you may not know about that, but in the earlier time, experts were using these kind of techniques, and manually they were manually generated these features by themselves, so that they can train a model without using neural networks, right? But with the deep learning, when you provide enough data, these models themselves can identify these edges and they can learn. That is a very big advantage. And in the middle part of layers would identify much higher level features like the eyes, the noses, and so noses like this, and eyes like this, right? Different forms of eyes, different forms of mouths, right? And so on. And so this is a basic one. This one is a much advanced form, which consists of much uh, complex structures of the image, like noses and eyes and mouths. And the later stages of the layers would identify much higher structures, like facial structures, like so, which are consisting of several such features, like several eyes, noses, right? Here you can find there's a part of feet, excuse me, part of the face is included in each of the image, right? So in each of the layer can automatically identify features that are significant, and they would learn each of the box, each of these squares corresponding to each of the feature in this layer, right? So these are some of the, this is one feature, this is one feature, this is another feature, right? In this layer, right? In higher layers, you can identify much higher advanced features automatically, right? This is something very important, and this is very wonderful if you think in that point of view, because this happens without any guidance. You don't have any experts or any person, human, instructing this algorithm to identify edges, faces, or parts of faces in any way, right? So the model would automatically identify these features in each of these layers, and that is the power of deep learning, right? Okay, now you would think why deep learning has got a sudden popularity in last couple of years. There's a reason for that. Actually, most of the machine learning algorithms were there since several decades ago. For example, the stochastic gradient descent was found in 1952. And this perceptron algorithm, right? Oh, the neuron concept was invented in 1958. And how to learn the neural network using backpropagation, right? How to train a multi-layer perceptron was invented in 1986. The inventor of this backpropagation algorithm was Professor Jeffrey Hinton, was awarded with Turing Award and Nobel Prize in Physics. He was awarded the Nobel Prize in Physics in 2024. So, however, his invention was done in 1986. Deep convolutional neural networks were found in 1995. So why this was too late for getting it popular? There are mainly three reasons. One is that these models, deep learning models, are highly data hungry. That means, unlike traditional, excuse me, unlike traditional machine learning models, these models needs a lot of data to be trained. These large data sets were available in last couple of years because of the development of internet and some large corporations that are using big data. And the hardware to process the neural networks were not there at that time. Excuse me. But now the GPUs and massive parallel massively parallel hardware to process matrices and tensors are now available, right? And the software like Python-based TensorFlow and PyTorch are now available, right? That is how the deep learning was possible in the later in recent days, right? If you look at the application of deep learning, you will see that sorry, that some now people are talking about AGI or the artificial general intelligence that is possible with deep learning. Some say it is already there with large language models. Some say it is yet to become, and sometimes it is very close to the AGI. However, we know it is very close, right? Sorry. And these computer vision applications are possible only with deep learning, like image classification, face recognition, medical image analysis, self-driving cars, video summarization. Those were not possible with traditional machine learning algorithms. And natural language processing tasks like text summarization, question answering, and machine translation, those were not possible with traditional natural language processing techniques. They were only possible after the deep learning revolution, mainly after the invention of large language models with transformer model. And there are speech recognition tools techniques as well. Sorry. There are speech to text and speaker identification and speaker verification technologies were also invented. These are only some of the deep learning based doors that were opened in the recent past, and that is why we are going to learn about deep learning. So let's finish our lesson. If you have any questions, you can ask.